This conference will now be recorded. This conference will now be recorded.
Hello friends, welcome to the demo session or the workshop on applications of data science. So we started a few minutes late. That's just to accommodate people. People will be slowly joining. So I thought we will start a few minutes late so that everyone can start from the beginning. So just a few suggestions before I start the workshop. I would request everybody to please go on mute if you are not speaking. You can just mute your session, mute your machines, laptops, whatever it is. And please do use the chat window. There is a chat window available. So that will be a very easier approach to ask any questions if you have. And certainly I'll give some pauses in between to ask any questions. If you have any questions, you can certainly ask questions, like you can speak out questions at that time. But I would encourage to use the chat window so that it doesn't hamper the flow. I look at the chat on my other screen, and definitely whenever I see some interesting questions related to the topic, I will blend them in the topic and then answer them, so that it would be better for everybody. They don't feel that I have stopped the session and answered any questions. So these are the few tips and suggestions which I would do. Please mute yourself, and if at all you have any question, primarily use chat, or else wait for the right time. I would give some breaks for question answers, and we would take questions. So this workshop, we are trying to do it for 2 days, today and tomorrow. I would highly urge to encourage people to attend both of the sessions. So today we will start it with a very basic understanding of data science and other things. And in tomorrow's session, I would also talk a very interesting end-to-end applications of data science, where we will see like how real-world applications will be developed, deployed, and tested. So that's an interesting topic. So I would urge to attend both of the sessions if possible. Certainly, there will be video recordings for these sessions. So even if you have missed some part of it, certainly you would be able to get the video recordings. But being in the session is a different thing. So with that, we will start the session. My name is Sitaram, and I have around 15 years of experience. In data science, I have around 8 years of experience in the primary data area. I started my career as a mainframe developer, so it is 15 years back I started, and slowly I worked in legacy modernization Java. Then I moved into Hadoop big data world, MongoDB big data. So from 2012 onwards, I was in the big data area. So I used to work as a big data architect, then a data architect, and for the past 3 years, I've navigated into data science as a data scientist in my organization. So I work full time, and this sessions is something as a part-time gig, I would say. I have a great passion in teaching, so that's the reason I also spend time over weekends and over the weekdays giving some training sessions. In fact, I have collaborations with a lot of consultants who request me to take some sessions. So Career IT is one of the consultant who collaborate with me for many years, and we together conduct a lot of sessions. Apart from sessions, I also conduct a lot of workshops, some conferences. I go to colleges, I go to different institutes for conducting sessions for their students, and that is also my passion. And from an education background, I have BTech from JNTU Hyderabad and in electrical engineering, and then I did my master's in data science from BITS Pilani, and currently I'm pursuing my PhD from IIIT Hyderabad, and I'm originated from Hyderabad and I stay in Hyderabad. So that is about me a little bit. I would love to spend time understanding about you, but certainly it will take a lot of time, and I will definitely hear back from you later. But without any further ado, let me start the session. So data analysis has been around for a lot of time. So there are many premier people who have worked in the area. A lot of experiments were conducted since 1930s onwards, trying to collect data, trying to store data, provide some quality control, understand data from a business angle, provide business intelligence systems, finding exploration of data, doing data pre-processing, applying some algorithms, doing machine learning. Likewise, there were a lot of these areas where people were understanding of data analysis. So that says that data analysis is not a new term. This is not at all a new term. This is a very, very old term. A lot of people are doing this for centuries as well. Like, the old cavemen also do a lot of data analysis. The old merchants used to do a lot of data analysis. Recent past, over 100 years, there were a lot of experiments done by famous researchers in this area to try to extract information from data. People have collected huge amounts of data, so they try to create means of extracting information, and they were doing a lot of these analysis. But what is that new thing which we are seeing right now is something which is important. The new thing, so the AI is a significant part of data analysis. AI means artificial intelligence. So data analysis requires a lot of hard work where people are involved in trying to extract data, clean data, munge it, do some pre-processing and all that stuff, and try to apply some algorithms to understand the insights of the data. Now, AI, artificial intelligence, has emerged as a field where we are trying to make computers to do the work of what humans try to do. So it was there for many, many years. Again, initially started in 1950s. The initial years of AI, there was a lot of hype, thinking that AI would change the world, and it's going to do a lot of great things and all. So this is somewhere around say 1958 or so, where initial perceptron models were developed. Perceptron models are the initial artificial neuron networks where we are trying to take data and try to predict what is going to happen in the future. So instead of happening in the future, they were tasked to guess some activities and perform those activities. Those were the initial perceptron models, which were binary models, which either do yes or no. Such kind of models were developed in the initial 1950 years. But later it went into a AI winter. AI winter is nothing but, there was a hype cycle. People thought that AI is going to change the world, but later it went into a hype winter cycle where then again people thought that, this is a sheer waste of time. This is not going to change the world. It's all crap and all. So then what this AI winter, the reason why this AI winter came is because these perceptron models were tested on data, but there was no data available, for testing, right? So why the data is not available? Certainly data was there, but there were no means of storing data, right? So there is no storage. So that is the primary part. So the storage devices back in 1950s, now we are talking 50, 60, 70 years back, those times the storage was very, very limited, and people were not having enough amount of storage to store data. So leave about videos, images, and speech samples, they were not even able to store key value formatted text data or your RDBMS style kind of a data. Even if you remember, RDBMS came somewhere around 1970s. So on those years, the people were storing as a flat file format or punched cards. So that was the time when there was no storage capacity, so that actually failed miserably. Then later in 1970s, 80s, there were advancements in AI models, typically called as backpropagation. So backpropagation is a very cool algorithm which was developed by Geoffrey Hilton, and this was one of the breakthrough algorithms for creating multimodal neural networks, which can do predictions with multi-class classifications, regressions, and other things. Now, people then again thought that, okay, this algorithm now it is going to change the world, and then there was a second hype cycle, and hype cycle was there, but because now the storage was available, but they were not having the enough compute. So compute was not there. So what is the difference between storage and compute? Storage is the ability to store data. Compute is the ability to execute commands on the data. So you need a good amount of CPUs, good amount of GPUs, and so on. So people started doing analysis on images, videos, handwritten character recognition in 1990s, and so on. There were good algorithms developed like CNNs, Professor Yann LeCun and other guys have developed a lot of good algorithms, but because of unavailability of compute, compute talks about the ability to have high-end computers which can look at the stored data and perform some operations. So in 1990s and all, people were now able to store it. Now we got good amount of storage systems, unlike the 1950s. But what happened is we still do not have a lot of computing capacity. So computing capacity was not there, and because of that, it again went into AI winter. Now we are in the phase 2017, 2020, 21, where we are again picking this hype cycle. So we are currently in this particular stage, I would say 2021, where people are now thinking, are we at the tip of the iceberg? Are we going to fall again? So are we not able to see all the bad things coming up? So people are a little skeptical at this point. So they might think that, okay, AI is going to become so cool that it is going to invent a lot of things, or maybe the system will stay there, and new applications will come, and slowly it will evolve. So I am picking up this thing. The reason is because there are three things which are contributing for AI to sustain. The first one is we have good storages. From a storage perspective, thanks to big data. So big data, then so we can say cloud computing, right? So we have good storage capacity is available. Now we have distributed data, distributed computing systems available, and other cool systems available right now, where we are able to store huge amounts of data, and we will be able to process it. Second one, the good thing which is happening is you have compute, very high-end compute, I messed up the spelling, but you get it. So compute, we have good amount of compute. We have high-end CPUs available. We have GPUs available. And in fact, we also have tensor processing units from Google, which will be able to do high-end computing of your data. So the time which was required for running some models, it used to take a lot of time, but now we are able to run the same thing at a very, very faster pace. So that's the advantage of compute. And the third and the most advantageous thing is the availability of algorithms. I can say algorithms. Since 2017 onwards, there was a lot of traction in Python. We have good algorithms like TensorFlow, which was open source. We have PyTorch. So what we are seeing here is there is a lot of adoption for a lot of these algorithms and programming systems where it has actually skyrocketed. And because of this happening, what we are seeing is there's a lot of advantages from an algorithmic perspective, from a compute perspective, and a storage perspective. And all these three things coming together, what we are hoping is this is going to stay for a long time. Now, if you ask me how long, Sitaram, then I would say at least 5 to 10 years. So I would say 5 to 10 years is the time frame, and after that, you might get some mixed technology. So you might say like cloud computing for DevOps plus data science plus something XYZ can come, and that would become the next mainstream. But this is here to stay for this duration, because there are a lot of applications which are kickstarting. A lot of people want to, data is a very essential part. It's a mainstream thing. So it's a very important thing of your organization, and whoever works on the data, definitely they're going to stay for a quite long time, right? So that is the cool thing. So we are seeing that the data is growing at a very enormous pace. So this particular thing is talking about 2018, but now we are at 2021. So this graph could have gone in the same pace. So what we are seeing is there's a huge inflow of data, huge storages of data, multiple systems which are providing huge amounts of data. And thanks to all our newer systems, could be the mobiles, connected devices, or sensor networks, or any other things, whatever we are currently using, all of them are actually generating data. That could be your Fitbit or MI band or whatever. So all these systems are kind of generating data. A huge amount of data is getting generated, and we are also having the capabilities, as we saw in the previous slide. We are also having the capabilities of storage and computation. So this is becoming like a deadly combination, that you're kind of getting huge amount of data, you're having good amount of storage and computation, and all these things coming together, you're trying to build better systems. Now, when I'm talking about data, what is this data comprising of? So we will try to look at some of the interesting applications of data, or what are these data types. So first and primary data type which typically be used is the transactional data. Now the transactional data, as the name suggests, it is like your regular transactions which are happening. So imagine I take a company which is a retail company. So what will be the regular transactions of a retail company? A retail company might be selling some, groceries. It might be selling some basic products and service, basic products and small things it is selling. So every day, whatever sales happen, those sales data will be captured in databases. Typically, that becomes your transactional data. So you take some mart. So imagine you are selling 1 kg of sugar, 1 liter of oil, and some other XYZ, maybe one packet of milk. And so if you're seeing, these are all the transactions. So how many people bought milk, how many liters of oil is sold, how many kgs of sugar is sold. So we want to do understanding this analysis. Now, the reason we want to understand that analysis is we want to plan for the demand and supply, and we want to ensure that the customers are getting the stock, and they are not going away to other competitors. So we want to do that kind of analysis. So primarily, many years back, people started using the transactional data. Typically the data will be using RDBMS. So RDBMS is systems, you can say SQL, Oracle, your Postgres. Now, these are the prime systems which are used for doing this transactional processing, right? So the RDBMS is system which help in storage of all these data. Now I talked about retail, but if you talk about banking, now banking also involves in money matters, transactions of money. So one person transferring money to another person, person doing spending. So we want to understand what are the spending patterns, what is the monthly average balance and other things. So if I know the monthly average balance, then I know that my bank will have so much of money lying idle with us every month. Then that money could be rotated, right? So what bank does is they actually take a monthly average balance of every person. Likewise, they collate the monthly average balance of all people, and they get an estimate of how much money is lying idle in the bank. Now, once the bank knows that that is the money lying idle, then based on that, they will take some risk estimate, and based on that, they rotate money, right? So the money doesn't sit there, right? So they are giving loans and doing other things. So, but how much loan they can give? If everybody goes to the bank and then withdraws money, then the bank is gone, right? Because they can't lend out that money. So they do a lot of analysis to try to understand like how much money is there, what is the average balance, um, uh, what is the risk available appetite, so that they can lend for loans, how much they can lend for loans and all that stuff. So there is a lot of work happening there to do that analysis. So there are a lot of systems developed. Again, all of them falls under the transactional data, right? So transactional data helps in to do the storage. Primarily storages are RDBMSs. In the recent years, people are also storing in NoSQL systems. They're also storing in NoSQL systems like MongoDB, DynamoDB, and other kind of NoSQL systems like Redis, Rake, and other ones. So this is the transactional data. So apart from the transactional data, people also have a lot of other data types. Now, other interesting use cases are audio and experimental data. Now, audio data, we are now very familiar with these applications of audio data. Now, you could talk about Siri, or you could talk about Alexa. Likewise, you could talk about, say, Cortana, Google Now, right? So there are a lot of these applications which are actually having an ability to interact with people. The people can interact with the machines can also respond to people, and there's a lot of systems getting developed in the space where they are using this speech understanding technology. Now how does a speech get understood? So there are a lot of, again, algorithms in this space where there are speaker identification, identification of voices, extracting information from speech to text conversion. So there are, again, sub layers of applications which is used in AI, where a lot of such kind of systems are created. So imagine you're talking to Alexa. You're saying, "Hey Alexa, what is the weather today?" So now you should dissect all the things which could happen within that. You're seeing that, okay, you're speaking first, then Alexa should first understand like what you're speaking. Now you say, "Hey Alexa, what is the weather today?" Now it should understand that what you have spoken is what is weather today, and then it takes that information, convert into some textual format, and then probably query the backend search engine for the weather, gets the weather information, and then converts that weather information into a audio format. So what we are seeing here is multiple these sections of information which are happening, and all these different sections can be combined together with different applications of AI, and all those things could be served together. I am very fortunate. I am very optimistic that in the coming years, we are going to see a lot of devices which will talk to us. Maybe our fridge will talk to us. Maybe our AC will talk to us. Of course, TVs are already talking. Are talking in sense, we can interact with TVs right now. You can say, "Hey, TV, turn on or turn off, or put this channel," or something like that. Gaming systems certainly are interacting with people, but that will go to the next level where most of the devices will have interacting ability. and there is a humanness coming into the devices. Now they are like plain non-living things, but when you have these interactions, definitely in the future, I am very sure that all these things would come into place. Definitely trying to give more comfort and more uh, facilities for humans. And the technologies which are used behind it is AI. Next set of this thing is experimental data. So the experimental data, what I'm talking is there are a lot of experiments which are conducted, and now that could range from oceanic research experiments, space research experiments, environmental sciences, experiments related to some chemical transformational process and so on, drug related thing and so on. So when you do this experimental process, you apply a lot of statistics and machine learning here, and we need to rightly guess like what is going to happen. If you take, for example, the case of COVID. So COVID vaccination, imagine you're taking the COVID vaccination case. So there are a lot of drug companies who are trying to, there's already vaccination is already there, but now there are a lot of drug companies who are worked towards getting that vaccination, right? So in getting that vaccination, there are certain processes which needs to be followed. They can't create the vaccine and give it to people. They need to do a lot of stringent tests. So imagine there are 1,000 people whom they are thinking that they have to give vaccine. They take a sample. So this 1,000 people are called as population, and they take a sample of say 100 people, and this is called as a sample, and they do experiments on this sample. So what are the experiments? They try to see like how this vaccine is working. Is it having any side effects? Does they have any complaints? Is it working or not? They do multiple tests, and then based on multiple tests, they confirm that okay, this is good, this works, and this could be extrapolated to the actual population. So the same thing happens for any vaccine or drug. For example, I want to invent a new drug for fever, say like aspirin or crocin or Tylenol or whatever. So I want to invent the drug, then it takes a lot of stringent process of these experimentations. A lot of statistical testing has to happen. We try to do this population sample mean testing, and then once the samples test results are good, then you extrapolate that results to the actual population, so you get meaningful output results. So that's how it works. So experimental data, I'm just talking about this COVID case, but the experimental data can vary in very varied varieties. You could do it in environmental sciences, you could do it in geology, you could do in earthquake seismic wave detections. So there are a lot of work happening in multiple areas where we are trying to collect data, do some experiments, and based on the experiments we are trying to extrapolate things to happen. Another interesting area, in fact, the two linked areas, this is video and image analysis, right? Image analysis, let us take first. So image analysis is very useful. It is already in mainstream right now. You could use image analysis for identifying a lot of things, especially in healthcare. And if you have seen Sundar Pichai's Google I/O speech in 2000, I think 2017-18, what he has what he has what he has said is that Google is using the application which Google uses is called as Verily, and it is used for detecting something called as diabetic retinopathy. Diabetic retino. So it uses something called as the diabetic retinopathy for identification of diabetic retinopathy, where the people who get more diabetes, right? What happens is slowly they lose their eyesight, and people in the rural parts, they think that that is because of their age or because of some XYZ reasons they are losing their eyesight, but they are really do not know that that is because of their bodily diabetic and conditions and so on. So because of that, Google, what it did is they have created this Verily, um, and and they have provided this application to two major hospitals in India. One is Arvind Eye Hospital, and the second one is Shankar Netralaya. So they have given these applications to these two primary hospital chains, and what they do is they can look at these retinal scans, and the systems are developed in such a way that we could look at these images and can classify whether the person is having diabetic retinopathy or not. Now, when a doctor looks at a retinal scan, now he or she identifies the cotton swab kind of things. There's this little spots which will be there in the eyes, retinal scans, which will tell that the person is having diabetic retinopathy or not. Now, the same steps are being identified by the algorithms. The algorithms which involve deep learning and other technologies, which can look at these retinal scans. Request you guys to go on mute, please. Thank you. All right. So what we are trying to see is we are looking at these diabetic retinopathy could be identified by the retinal scans, and if the systems look at the retinal scans, they will be able to identify whether the person is having diabetes or not, right? They are having the diabetic retinopathy or not. And likewise, there are a lot of systems which are developed by just looking at the images, by scanning the images, by getting the patterns from the images. We are able to take some decisions, right? It could be your face unlock feature of your mobile phone. You could see like how is it working. When you initially got the mobile, it asks you to scan your face for a couple of times, and over it looks at your face and then try to create a model of your face. And even if your face is having spectacles, or maybe you have a beard, or you have a different hairstyle, so it still tries to identify you, because it has seen you over and over again, and the model has updated itself so that it can identify varied patterns of your image. Now, image analysis is very popular in healthcare. It is very popular in media industry, and other areas where we are trying to understand the patterns of the images, and we are trying to create systems. Even there are a lot of applications which are cool applications which are developed, where looking at the images, I would like to categorize things. Recently, image-based automatic gate entry and attendance system kind of systems came into the workplace, where because of COVID, you don't want to do scanning, touching, and other things. So there are security cameras which can look at you and identify you, and basically open your gate. So such kind of systems are created. Again, they are based on image based analysis, right? So if you are looking at it, it can also be useful for radiology, X-ray scans, CT, MRI scans, and other skin conditions. Yeah, so basically definitely it is used for a lot of other systems. Now, coming to the video analysis, it is like the advancement of image analysis. Now, video analysis is where instead of images, you're taking a video of maybe like a security camera, or maybe like a video stream or somewhere. So you're basically taking the video of your data and looking at the video and trying to identify certain patterns and things. It could be an activity detection, it could be identification of fraudulent things, it could be security alert systems, and so on. So, IIT Hyderabad, I know professors who work there, and they have recently worked with municipality of Hyderabad. What they're doing is they're trying to create systems which can take the feeds from traffic signals and identify people who do not wear helmets. Now, that involves multiple steps of processes. So it has to take the feed from real-time feed from the traffic cameras and identify people who are not wearing helmets. So that is from an image, that is an easier part. So you can identify people, heads of people who do not wear helmet, right? So if you are wearing helmet, you can identify that. If you're not wearing helmet, the system can identify it. So that system is easy, but it goes a little beyond that. If it identifies a vehicle, a person who is not wearing helmet, it will also scan the number plate of that particular person, and then scans the number plate and automatically cut a challan for that person. So the systems are being developed where we are trying to create these integrated systems where we can use this deep learning techniques, where we can look at the videos, identify people, identify the violation, and scan your number plates and get the information from number plates and automatically uh, apply fines to the vehicles. So such kind of systems are developed, and these are few examples I'm taking, but definitely there are huge amount of application areas, again in the space of e-commerce, in the space of media and finance and other things. People are trying to use this surveillance kind of systems. And last but not the least, there are a lot of these graphs and charts and stats which basically are also used as a data representations. We have huge amount of data which is flowing through the systems. So we're trying to see these data systems which are passing the data, creating these graphs, and we want to create systems which can infer from these charts and other graphs, because picture speaks more than 1,000 words, and if you are portraying the information in terms of pictures, you get a lot of insights. That's my personal feeling also, and you would see that all my presentations will not have any theory kind of a thing. Most of that would be in the picture format. So you will get a lot of information from these pictures, and when you showcase the information, as a data scientist, we need to be able to portray our information in terms of graphs and charts and so on. And what we see is we try to devise systems which can draw these graphs from the data. Instead of me showing an Excel sheet with all numbers, if you try to draw a graph, maybe a bar chart, a scatter plot, or different kind of plot, they will be able to give us some kind of meaningful insight of what the data is speaking. So making sense of these graphs and charts and different statistical things also really makes sense for a data scientist. So the person should be able to having an understanding of these visualization tools, and he or she should have an understanding of how these tools are applied. So that is also an important thing. Right. So looking at this data, I have only talked about few data. Apart from this, we have a lot of sensor data, textual information. All those things are being considered, and all those things really make a data for these applications. So going forward, we will take a step back and do a little theory, understand about what is artificial intelligence, what is machine learning, deep learning, and what is the relation of data science with all these things. Those are different topics. In fact, people use it interchangeably and other things. But let us try to do a sneak peek into these words and try to understand what is these all about. I might sure be you might be knowing all these things, but let us take a small sneak peek. So AI, it's a general, you can call it as an umbrella. So this is an umbrella which is basically housing your machine learning, deep learning, other related algorithm things. But primarily AI was designed uh, to make humans' life easy. So there were a lot of these there were a lot of these manual tasks which humans were performing over the years, and they wanted to automate these manual tasks and make computer work for them, right? So it was the initial years in 1970s and 1980s where people were thinking that, let us create systems which basically do not involve humans interaction, and we will try to make the systems do the work of humans. So primarily what they designed is they designed some logics, some rules, some steps, some decisions for doing certain tasks. So you're doing one task. For example, an automated machine is trying to make these packaging boxes. Okay, these carton boxes, right? The packaging boxes, they could be automatically made. So imagine you get a piece of a cardboard, and you want to make that piece of a cardboard into a box. Now, how do you do it? You turn it left, turn it right, you turn it around, and then you make a box out of it. If you can list down all the logic steps and rules for making that box, you can then give those rules to the machine and ask the machine to do the same thing. So it will get a piece of cardboard, then after that it will turn the piece of cardboard into a small, likewise, then it will turn likewise, then it will make a box out of it. I'm trying to draw. So your piece of cardboard will become a box like this. Is like a final product. Now what we are trying to do is we are trying to give these rules to the machine so that it can basically identify where it has to turn. So it has kind of turn this first, then this second, then it has to turn it around, then there will be a flip here, you could take that, and this one. So finally you try to create a box out of it, and all those steps will be provided to the computer, so humans work will be minimized. So there are a lot of these automated tasks. So initially AI started like that, where we want to make computers do the work of humans. So where humans are doing some other important things rather than these manual monotonous works. Initially it started like that, but the requirement for AI is to provide these rules and logics and steps and decision making things. Now all these things need to be provided by humans, right? So that is the toughest part. So you need to know there are subject matter experts who know like what are the different steps, so that they can provide an AI machine with all the required steps so that it can make the rules and then create systems. That is how AI started, and now we can call that as automation and robotic process automation, and different other things are coming up, but the thought process of that was AI. When you go deeper, people said that, okay, there are a lot of data, I am not able to make sense of this data, there's huge amounts of patterns, then we will not be able to manually design these logics and rules. I can give some base rules, but getting to great amount of accuracy, we will not be able to do it. So these rules cannot be identified by humans. So let us design statistical systems which can look at the data, identify the patterns of the data, and come up with the rules by itself. And that is what is called as machine learning, right? Machine learning is a science where it uses statistics. So it is using statistical techniques for making sense of data. So it gets huge amount of data. It gets data from different systems. It gets data from different databases, flat files, and all that stuff. You are dumping the data to the ML models. And what these ML models will do is it will use some of the algorithms. If we do data science course, we will see that there are a lot of these algorithms which would be utilized for finding patterns of the data. And those patterns, once we create an what we call as an ML model, now that model will be used instead of a human. We will be using that ML model for understanding data and making some future decisions, right? Instead of we using a set of rules, the ML model will be designed. Now, ML model, you can think like it is nothing but a abstraction of all the rules. It is an abstraction of all the rules identified from the patterns of the data. It will create this model, and using the model, we will be able to do the predictions. So if I look like a smaller way, you would get, so you will get input data and you will get some outputs. You create an ML and output would be a model. This is how it would work. So you are providing input data, you're providing output data, and you try to do some ML algorithm, and finally you'll get a model as an output. You can call this model, or you can call this as a program, or in a very raw sense, you can also call it as a formula. The formula is what? It is a representation of my input and the output data. So you have some inputs and outputs. So a general linear formula would look something like this: y is equals to mx plus c. So this is the equation of a line, but this is the formula which is representing output y and input x with some linear understanding. So likewise, there are a lot of these algorithmic representations of data where we try to look at different values of inputs and outputs, and based on that you construct a machine learning model, and further the model could be used for doing predictions. Now there are some data types. Now what are the data types which are very suitable for machine learning models? Those are structured data. Now structured data in terms of tables, in terms of files, such kind of formats are very good in understanding this particular records. But when coming to data types like images and other things, it gets very difficult for the machine learning models. So there are a subsection, or in fact there is a subdivision of machine learning. In fact, deep learning is a technique which uses something called as neural networks, which is a subdivision of machine learning, which is specialized in working with unstructured kind of data types. For example, it uses speech samples, images. It uses different kinds of other tasks, which uses multi-layered neural networks to identify the neural network based algorithms for finding patterns in images and videos and speech samples accordingly. So whatever application we talked around images and video data will be used by deep learning. Now the deep learning is a sub area of machine learning which works on these specific tasks and be able to do predictions. Now that is what deep learning talks about. Now what is data science, right? So this is AI, machine learning, and deep learning. This is everything good, but now people will ask, what is data science? Now if you're looking keenly into this area, this is talking about all about algorithms, right? It talks about algorithms to find patterns. It talks about algorithms to look at the data, understand the variations in the data and other things and so on. But where is the data? Who will get me the data? How do I create the model? How the model will be deployed? Who will be taking care of the deployment of the model? See, all these things are unknowns here, right? Somebody should get us the data, right? So there are systems who are getting us the data, but when I'm getting the data is it in a consumable format? Do I need to do some pre-processing of the data? So there are a lot of connected things. There are a lot of connected dots. For example, we call data ingestion. It's a huge area which involves in getting your data. So are you getting data in real time? Are you getting data in a batch format? How are you getting the data? So there are a lot of tools and techniques which are involved there. There is a data transformation. So transformation or pre-processing. So data transformation and data pre-processing involved, which is also a lot of technologies involved here, where because my data is not in a readily consumable format, you might get the data from multiple tables. You want to collate all the tables, create some transformational views. You kind of create some final set of transformed data, clean data. So that clean data has to be sent to the machine learning models. So if you're not sending the clean data, you're sending garbage to your machine learning models, you will get garbage results. So the purpose is you need to do some exploration of the data, you need to do some transformations, pre-processing, standardization, normalization techniques, scaling and encoding techniques. So there are a lot of these techniques which would be applied on the data. And once you apply on the data, you will transform your data so that it becomes in a consumable format. That consumable format data will be fed to your machine learning models so that machine learning models will create your outputs. Now that what we are seeing here is that pre-processing, whatever we are talking, again falls under data science. Now, once you create a model, now you have to create as an API, right? You create a model, you want to create as an API so that it could be consumed by external systems, right? Now, machine learning model is a mathematical modeling technique, right? But you want to create this, whatever model you created, that you want to create it as a executable. So you want to create an API which is using this model, which will have some endpoint, which will accept some inputs, give some outputs, and that could be called from a front-end system. It could be a website, or it could be a mobile, right? Android and iOS. So whatever it is, it has to be consumed by these devices. And for consuming, you would create some APIs, and you know like how to deploy that API, you know how to deploy the model and all those things. So after creating of the models, you also have again some connected things related to the model deployment, model inference, what we call, and then how do you create APIs and render those models. So all those things are involved. Again, those are all involved in data science. Data science also involves different visualization techniques. So there are a lot of visualization techniques which we have to apply to understand the goodness of the models. How is the model good? How good is it? If I want to change some parameters of the model because the model is not good, so you want to do some changes to the model. So you apply all these techniques for doing different what I mean to say is different processing techniques in which you try to process your data and then visualize it. You see, like if the visualizations are not giving right right accuracies or right metrics, you try to change the model by model parameters and try to create better visualizations. So there are all these peripherals. What we are seeing here is we are seeing all these peripherals which are connected to this modeling, which will make the work happen. So from a business angle, if you're talking from a business angle, I want to get certain things done. So for getting that certain thing done, your AI, ML, and DL becomes the core piece, which talks about the algorithmic part. But there are a lot of these connected things which talks about how do you bring data, how do you transform data, how do you visualize it, how do you build models, how do you deploy them. So all these things work as data science. Are you guys following? So I just want to check if you guys have any questions right now. So we just around 1 hour time frame now. So I just want to check if you have any questions here. Are you guys following? You can use the chat window to post any questions you have, or you can speak out.
Yeah, one quick question. Like in this
Hello.
article, here we have the data ingestion, data transformation, and all these things, right? For data science.
Yeah.
So that will be in a manual, right? That is all manual jobs.
It could be manual, you can automate it also. There are systems where we can automate things as well. But yeah, it is a semi-automated or manual kind of a thing. So data ingestion now, I am doing a physical movement of data from one system to another system, or I create a job which can automatically bring data. Every day the job is scheduled. Every day night, say 8 o'clock, I have a job which brings the data from system A to system B. Then then we run all these things. So we can automate that also,
Right.
not
And
necessarily.
yeah, so once that data is given to this machine and once the ML model is generated, again manually we also need to validate that ML model, right?
Yes.
Okay.
Yeah, correct.
Okay.
We have to validate the model. We have to find out whether the model is good or not. Even that could also be automated. There are systems where you can automatically run multiple set of parameters and identify best model out of it, and then can extract the best ML model. That is how it comes out.
Okay.
Right. So there's a question that does the API belongs to AI? Now, if you look at the entire view of how this works, now if I create just a AI model, that does not help us, right? So you might need to create a executable out of it, an executable which could be consumed by the external world. The external world could be an automated robot, or it could be a mobile app, or it could be a website which is calling your model. Just as an example, if I say there is a bank, so Bank of America or JP Morgan Chase or something, which is wanted to create an automated loan approval system. So a loan approval system looks at 2 years worth of data and creates a machine learning model, and that model expects you to give some information. So what is your age, what is your monthly salary, what is your bank balance, other liabilities. For example, do you have any home loan or car loan or personal educational loan, or are you married? If you are married, do you have kids? So these are all these questions, right? So the website is created in such a way that all these questions are asked, and then you collect information from that, and that information will be sent to the machine learning model. Now you can create an API. An API doesn't directly be a part of your AI, but it is a connected piece where it is basically connecting your front-end systems to your AI model. Now the API will interact with the model and then give the inputs to the model. Model will respond to that, say that you are approved. Say like, congratulations, you are approved for say 100K loan. So that's how the entire system would work. So there's a question that, can we consider data science as a bigger set, whereas AI, ML, DL are subsets? Absolutely. AI, ML, DL, they are the modeling pieces. They're called as modeling pieces of your entire data science purview. So tomorrow I'll talk about how this entire thing flows. So that would be an interesting session to really understand about how things flow from one system to another system. What are the different tools and techniques which are used in that? But but as you rightly understood, data science is a bigger thing, which is connecting all these different pieces, and where AI ML becomes the integral part of it. So there's a question that how do we define the rules and pass it to AI? You said it is manual efforts, and will ML do that? So it is, yeah, you could set those rules. The rules are nothing but, now what I'm saying, rules in sense, ML will identify the patterns. So when I pass the data, you are trying to identify the patterns of the data. For example, let me give a simple, I want to make you guys ML. So let me see. Okay, I will utilize this space. So if I have data, so I have x1, I have x2, I have y. There are two input variables and this is output variable. So I have 1, 2, 4. Now this is the data given to you. Okay, this is the data set given to you. Is there any pattern? Can you guess it? Any guesses here?
It's 1 plus, it's x1 plus x2 plus again x1.
2x1 plus x2, y is equal
Yeah,
to x1 plus x2.
exactly.
Yeah, yeah.
What we are saying is my y, which I can say this is an output, and these guys are inputs. If I say my x's are inputs and this one is an output, I can say my y is 2 times of x1 plus x2. Now what we have done is we have done machine learning. We are the machine learning model right now, and we did machine learning. But how we did it, we are looking at these patterns and then trying to do some mathematical math in our brain and then coming up with this equation. But now imagine these are 1 million records, and these x values are like 50 x values, and y values you have so many. So once I'm giving these 1 million records, it is very difficult for us to come up with this kind of an equation. Now this equation might not be like 2x1 plus x2, it could be like 2.82x1 minus 1.52 x2 plus 3.61 x3 plus dash 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 dash. Like now I can have 50 parameters like that, right? So there could be a combination of these parameters, but getting to these parameters is very difficult for a human to do. That's where your ML will come into picture. So the automated way in which ML will identify the patterns between input data and output data. So there we use some algorithms where we can identify the patterns between input and output data, and we will be able to create this formula. Now, once the formula is created, now for a new value of x1 and x2, now if you know that this formula, now I give a new value of x1 and x2, say like 20 and 20, then you will be able to easily put this numbers into this formula. So now 20 times 2, 40, 40 plus 2, 20, that now it will answer y will become 60. That is easy for you. Now, that's how it really does the formulation. Did we get it? Am I able to clarify that?
Yes, Sitaram. Thank you.
So there's another question that as a beginner, can we use AWS or Google ready-made ML algorithm? How to choose ML algorithm based on business data? No, that is not a straightforward question. So a straightforward answer. So there are wide varieties of data. So depending upon the type of data, whether it is structured, unstructured, textual data, data with a lot of convolutions, data with a lot of sparseness. So there are wide variety of patterns of the data, and again there are hundreds of algorithms which are available. So there is no direct answer saying that okay, this is the data, this is the algorithm. So it doesn't work. There could be multiple algorithms which could better suit for different types of data, and there could be some specific algorithms which are only used for certain kinds of data. So it actually boils down to a lot of those things. Now, coming to the question, can we use some automated things like cloud-based ML models? They are still in the infant stage. So they are like still in the adoption stage where they are designed in such a way that they are suited for certain kind of data. but they are not generalized. Now I can't use this for everything. So they are no, they are auto MLs are something they are called, where you could use those ML models designed by the cloud providers, AWS, Azure, Google, and so on. And I could directly put the data to it, and then it can give my output. But it is not yet in the adoption stage. So when business data comes into picture, there's a lot of variations in the data. Now I can't use a general algorithm for solving all the problems. If you do it, your accuracy will be low. Now, if you're saying that I will use a general algorithm for predicting whether the person is having cancer or not, now you can't take that risk, right? So you can't say like, okay, 95% this algorithm is correct, 5% it is wrong. 5% wrong means it is really not acceptable. So in such kind of cases where you really wanted to go to the deeper levels, you wanted to optimize your system so that you get better accuracies, you can't use general uh, cloud-based algorithms. And that is the reason you require a lot of people who can design systems, who can build systems, and so on. Maybe after few years, as I was saying, 5 to 10 years, you might get this maturity in cloud and maturity in AI, and you can get systems which are trained based on a lot of data and can create automated systems which can do kind of auto ML kind of a thing. But at this phase, we are not yet reached that level. Got it? Any other questions? All right. So what I want to do, I'll take a few minutes break. So we'll give a few minutes break, and we will come back and we'll discuss about different applications of data science. All right. So we'll take a few minute break, and just put it in the chat so that everybody is aware. If you have any questions, do let me know. We can discuss now, or else we will take a small break here, a water break, 5 minute break, and we'll come back. All right, so we'll take a small 5 minute break and we'll come back in few minutes, and then we'll understand different applications of data science. So I'll go into individual areas. We will discuss about how those applications are developed. Many of them I have personally worked on it. So I'll give my personal understanding of how those systems are developed. All right, we'll take a 5 minute break and then come back, and then take care. All right, welcome back. So there are a few questions. Let me answer them, and we'll go to the next session. So there's a person from medical background and wanted to work on EMRs, electronic medical records. In fact, I have two examples on medical research. In fact, healthcare is a primary in applications of data science and ML and AI. So there are a lot of work happening, and that is kind of an interdisciplinary field. So if you are from a medical background, what I would suggest is certainly that could be helping you. In fact, in my previous course also, a few people who are from a medical background who did that work, but they are kind of a doctor or kind of a thing. So they are utilizing that knowledge for their application areas. Certainly, it is a very interesting area. It might not require engineering, but certainly it would require some programming knowledge. So you might need to acquire some programming knowledge for getting these done, right? So when you're applying models, you need to know some kind of programming. So my suggestions would be if you're not really into programming, I would suggest Python as an entry point. You could learn Python, and Python would help you to apply some easy machine learning models and do some research on clinical data. So that would be a suggestion. Okay, another question. Someone wanted to start a career in data science, and so what are the different roles in the data science and data analysts? And there are a lot of roles posted by Facebook and other things. Yeah, certainly people who wanted to do a career in data science, if you are like a fresher, so there are multiple answers to it. It is not a one straightforward answer, because my students, they will be from multiple backgrounds. Okay, people who are also already having 10-15 years of experience, people who are just started their job, like 1-2 year experience, people who are right out of the college. And so it depends upon where you are in this entire journey. So if you're already an experienced person, you have already done some work in other domains. So you could be doing maybe like mainframes or manual testing, or it could be a database administrator, or you could be doing different roles in your past. But if you're in that kind of a frame, then you need to improve your domain knowledge. You need to work on a lot of projects, and that will certainly help you to get into the role. I would certainly ask people who are already working, identify some roles within the organization, so slowly transition into that role, and then get some small experience, and then switch to another company, right? So that is an ideal way of doing things, and many of my students have already done that in the past, where they have slowly identified an area within their company. They offered some help, and people are very open to take the help. They joined as a small team member, as a part-time team member, and slowly got into the team. Now they have got better opportunities. They were leading teams and so on. So such kind of opportunities are there. Only that you have to identify people, have your right focus, and get into that. Now this is for experienced people. For somebody who is very, very new, they do not know anything, they want to get as an entry, the entry level job is called as an ML engineer, which is a machine learning engineer, who will be responsible for creating these applications, APIs, and model deployments, and all these things. So he or she will know a little bit of data science, machine learning. They will not be purely developing the models, but they will be helping in operationalizing the models. So if you are from a tech background, computer science background, that will be an easy role for you to transition to. ML engineer role. There is another role called as data analyst. That is also an entry level role, which does not require a lot of technical expertise, but that involves a lot of querying, SQL, Excel, a little bit of machine learning here and there. So that is an entry level role, you can say like a junior role to the data scientist, who will be helping into creating data, preparing data, finding patterns in the data, doing exploratory analysis. So such kind of work will be done by a data analyst. That is also a junior role to focus on. Okay, so I would I would suggest that tomorrow please do attend, because tomorrow I'll be talking about different areas, and there we will be focusing, like if I am from a, say, like a testing background, if I'm say from a testing background, now where is my entry door? So this entire area is a huge area, right? And there are multiple doors to different people. Now if I'm saying I am from a testing background, now what is my door? Where should I enter, and what is the role I should focus on, right? Now if you focus on the entire thing, then you would become a jack of all trades, but you might not get that entry. It becomes very difficult. So your focus should be very, very clear. You need to know, like if I am an ETL developer, so what is my focus? If I am a database administrator, what is my focus? If I am a front-end Java developer, what is my focus? So if you are very clear about what is your entry point into data science, then your entry would be easier, your penetration would be easier, right? Just a second. Right, so that is what we are going to discuss also. So there is another question, that should a data engineer remain a data engineer or transition to data scientist? That is a bigger question. A lot of things now data engineer, if people don't know what is a data engineer, the person who is bringing the data, transforming the data, doing all the ingestion, all those things, that person is called as the data engineer. Now it used to be a fancy term, big data and all these things used to be a fancy term 10 years back, certainly when when we started our initial engagements on big data and Hadoop and other things, it used to be the coolest topic on the world. But now, because there are a lot of things automated, and many of those primary companies who are responsible for these things, they are already extinct, I would say. Like Mapr is gone, Cloudera is on the verge of going. Those are getting transformed into some cloud-based solutions. Maybe the data engineering part might get also automated. So if you are already a data engineer, I would certainly suggest that you also have your foot in the data science domain, so that once you already know like how the data is transformed and all, it is just a one step away for applying some predictive models and getting some predictions, right? That would be my suggestion. Okay, let us get into the next subject, guys. So we will spend another hour or so. What is the time now? 9 o'clock. So we'll spend around another hour or so. We'll understand some of these application areas of data science. We will see if you have any questions, we'll answer them and then close for today. So that's the plan. So social media analytics. Now, when I'm saying social media analytics, now these are the companies who are the prime companies who are responsible for getting all these data related technologies. So the companies like Google, Facebook, YouTube, Twitter, LinkedIn, Now you name it, there are a lot of these companies who are having bigger problems. Now they are not having simple problems like what is how many kgs of sugar sold, how many liters of oil sold, what is the average balance of the bank. Now this is not the tools and technology, these are not the problems which these companies are having. The companies are having a lot more bigger problems, like how do you index different pages, how do you render most viewed pages, what are the recommendations for the next YouTube video. So you're seeing the problems are a little bigger, and for that they were not able to solve them using regular traditional RDBMS kind of databases. So they have designed systems like bigger systems like Hadoop, distributed file system based systems, and they have created algorithms which can run multiple NoSQL based distributed systems, which are doing better things. They have also released a lot of machine learning related algorithms. Frameworks were released like TensorFlow and PyTorch and so on, which are focusing on doing data predictions, applying models and so on. Now I would say that these guys are pioneers in getting these technologies onto the board and also open sourcing them. When the open source technologies are into the wild, what happened, other companies actually onboarded on them and then try to use the technologies for betterment of their systems. These social media companies started the wave, and other companies have picked up, and then they are using it for creating better systems for them. That's how it started. Now, after these social media companies, the best companies which utilized these models, machine learning models, are the finance, banking and finance companies, I would say. In earlier years, they used to use predictive analytics. Predictive analytics is a science in which we are trying to predict what is going to happen in the future. Now, future we have never seen. We don't know what will happen. We might have some corona XYZ. We don't know, but there is some guess which we can do based on the past data. We can guess that probably the future can look like this, because humans do not like randomness. We want to do some guess for the randomness, right? So we don't want to get fooled by randomness. We want to do that guessing. So what we want to do is we try to do this predictive abilities. So what people did is they wanted to identify patterns in the data, and then they want to predict these patterns. Primarily, the banking and the insurance companies, they wanted to identify who are the most loyal customers, who are the try to identify the credit worthy of the customers, some related things like what could be the loan giving abilities and all that stuff. So they used predictive analytics for using the data and predicting what is going to happen in the future. Prior to this also, predictive analytics was available, but the disadvantage was the models never used to run beyond a single machine. So they need to be run on the same RAM, but thanks to big data, cloud computing and other good technologies, all these things are combined, and we are trying to combine them and then use it for better systems, right? So that is how it started. Another interesting applications of data science are fraud and intruder detection. Now, fraud and intruder detection are again followed by these finance companies, banking companies, insurance companies, where they wanted to identify fraudulent transactions. Now, what is a fraud? Fraud is nothing but an anomaly. It's a different transaction which is not similar to the regular set of transactions. Now, fraud, imagine I try to draw kind of a graph. Now, if I'm trying to draw patterns in the graph, now this is the pattern of transactions which are happening. So you see that there is the pattern in the data. They are following some certain pattern. Now, you could have a pattern here, which could be a fraud. So when we try to identify these data, which is very, very different from the regular transactions. Now, if I draw an oval kind of a circle, now this is how the regular data is, but this data, the fraud which I'm calling, is very, very different from other data points. Now, technically, these are all also called as anomalies. Anomalies are the ones which are having different patterns, different behaviors to your data, and they are not representing your regular crowd, right? So to identify these frauds or anomalies, there are again multiple algorithms are there where we are trying to predict these anomalies. Just a second. So there are these anomalies and there are these patterns which we are trying to find out, and these anomalies are little different from your regular transactions. They are not following your regular transaction pattern. They're not following this herd. They are very, very different. And once we identify the anomalies, then we can check whether these anomalies are real or not. Now there could be a real anomalies as well. For example, you are a regular person, you get salary once in a month, you go to movies, maybe say like every weekend, once in 2 weeks you go to restaurants, you do shopping once in a month. So if this is your regular spending patterns, you spend it on fuel, you spend it on groceries, and these are your regular spending patterns. Suddenly you purchase a 4K television for your house. Maybe that's your birthday or your wife's birthday or something, and then you purchase this 4K television for your house. So you get a call from the bank saying that, hello sir, we see that your regular transactions, we see a purchase in your debit card or credit card. Could you please authorize whether that is you? Right? You do this, you do get these calls, and nowadays it is automated that you get an email and you get a message. But in olden days, people used to get these calls, and they used to authorize whether the person is the same or not. If it is not same, then the transaction will be kept on hold, and it basically will be delayed. Same case happens if you are a regular person who is staying in India, and you went to Singapore for a trip, but you did not inform your bank, and then you have used your debit card, which is an international debit card. So if you are using that, then you suddenly get a alert in your email, or maybe on your mobile, saying that we are seeing your debit card being used in a country which is not your own. Now, how it identified all these patterns is because when they look at your regular data pattern, it is following some kind of patterns, and anomaly or a fraud is something which is very, very different from your regular pattern. Got it? And we try to where we have algorithms where we can identify these anomalies, and once anomalies are detected, then we can keep it separate, try to apply different steps for identifying. So you can have a call center guy calling you and confirming whether those anomalies are really true or fraudulent. So such kind of things happen after that. Another interesting area is sentiment analysis. Now, sentiment analysis is a very, very common thing, and there are a lot of applications, especially e-commerce applications, are developed around the sentiment analysis, right? So if you are seeing, you go to Amazon, you're trying to purchase say like a mobile, the first thing you do is you go to the review session, you go to try to read the reviews, you try to identify the rating, you only select products which are like 4 rating and above. So all these things you're doing because you trust people and you think that whatever ratings given by the people is very good. But if somebody fluked it, and if you kind of created people 10, 20, 100 people who are just giving 5 rating to the product, but that product is only 3 rating worth, then you are like fooled, right? So that is happening because of the sentiment analysis which is being done. I remember that in early 2009, 2010, where we created a project, and this I created it for one of the car rental company in US, and their primary purpose was to rent cars. Okay, so you if you're in US, you really know US or other parts of the world, they people rent cars very often, and they go and take car from the airport and then take around in the city, stay there for 2-3 days, and then give the car back when they're going back home. So that's a very common thing, and in India and other parts also it is developing, but thanks to Uber, Ola, those companies are now getting extinct. But in those days we had this requirement that we wanted to understand the sentiment of the users, right? So we created a portal called as Voice of the Customer portal, where people have to log in. I'm talking about 2009 time frame, where people have to log into the web application. Mobiles were not so prominent at that time, and people have to log into the web application, the Voice of the Customer portal, and they have to give the feedback rating regarding how was the customer service, how was the car, and what did he feel about the entire trip, any suggestions. Like that, he has to give all the information, and we used to collect that information and then try to identify the sentiment of the users. The sentiment of the users was pretty straightforward. We were trying to identify whether the person is happy, neutral, or sad, and then we try to take the sentiments by location. By location, by region, like that, we try to create multiple unit level sentiments, and then we try to identify which particular rental location is having a very positive sentiment, which rental location is having very negative sentiment, and then we try to concentrate on the locations which are bad. Maybe the customer, the agent behavior is bad, probably the location is very poorly maintained, the cars are not poorly maintained. So all these things comes into picture, and then those used to be taken care. Now this is so many years back, but nowadays people wanted to create entity level sentiment analysis. Now, what is entity level sentiment analysis? That means that you wanted to go to pinpointed particular application, and then you create sentiment of that. So for example, I have a comment on, say, like Amazon.com or some other website about a mobile. So the comment goes like this. It says like, the look and feel of the mobile is great, the build quality is awesome, the battery backup is also good, the camera take crisp pictures, but the front facing camera is awful. Okay, so it has like 4 or 5 comments which talks positive in the first few comments. In the last comment, it says that the front facing camera is bad. That means that if I'm trying to create a sentiment of the mobile, I will certainly say that everything is good except the front facing camera. So from a customer standpoint, if a customer who is not worried about front facing camera, who is not worried about taking selfies, now he will purchase that camera. So somebody like my father, or who is not worried about selfies, who just worried about the battery backup and maybe the build of the mobile and responsiveness of the mobile, so they do not care about selfies, right? But somebody who is like a youngster, who is like college pass out, or probably who is in the young teenage, who is very selfie freak, then he or she would be worried about the front facing camera, which is like maybe a 1 megapixel. From a company perspective, the sentiment analysis would also give a very clear-cut, pinpointed information saying that if this particular front-facing camera is changed from 1 megapixel to say like 25 megapixel camera, then this product will be a super duper hit, because everything else is good, only people are complaining about the front-facing camera. Right? So the companies, the manufacturers, would again release a next version. Say like if they release some M10, they release M10S. So that the newer version, the S version, will have an upgraded front-facing camera, which is extracted from the sentiments of the customers. right? You see that when the product gets launched, right after few months, there will be an upgraded product of that. That is because they got all these feedbacks and then considered the feedbacks and upgraded the mobile. And you would see that the newer mobile will be a super duper hit. And that's how data science is helping these companies and also the customers to get better things of whatever they want. Self-driving cars, and now this is a reality now. If you take 5 years back, people used to only read them in books, but nowadays we are seeing that these self-driving cars are reality. We are seeing some of the cars driving on the roads, are going to different countries and other things. So we will see that these will become mainstream products in the coming years. And what they are doing is they are using reinforcement learning, which is one of the sub areas of machine learning. And reinforcement learning, what it does is it tries to get some feedbacks from your actions, and then based on the feedbacks, it tries to take next level actions. For example, I'm trying to create a self-driving car, and it is designed to stop at a traffic signal if it is red. And imagine it did not stop at the traffic signal, and then it has just passed the traffic signal a little bit. Then what happens is the reinforcement learning algorithm will penalize the model. So there is this reward and penalty mechanism. So the model gets penalized, and it next time it will try to improvise the model, and it doesn't try to cross the red signal, right? So likewise, the model learns by its own, slowly and slowly and slowly, and then finally create systems which will basically be used by other models after the learning of these models. There are other companies. You might have heard about something called as Boston Dynamics. It's a company which is creating humanoid robots, and these robots are trained throughout the day to do tasks which are done by humans. For example, the robots are trained for lifting heavy objects, robots are trained for walking, robots are trained for running, climbing the stairs, climbing down the stairs. So if you are seeing, there are multiple robots created, and every robot is trained on certain thing. Now imagine a robot which is lifting heavy objects and keeping it down, so that throughout the day it does the same thing. By doing that, it is basically learning how to balance. So the robot is created, it's like a physical machine, right? So it has to balance itself. There is this body balance and other things while lifting the object. So for the first time when it is lifting, it might fall down, 10th time it might fall down, but the 20th time it can slowly lift the object. By the 100th time it will know like how to lift the object very properly. So likewise, systems are created where these models are learning by the feedbacks, and once the model learns, the same learning can be adopted to the other machine. So the beauty is that once one machine is learning to lift the object, the other robot is learning to climb the stairs, the third robot is learning to run, the fourth robot is learning to swim. So we are seeing that all these robots combined together, you're creating a super robot which will be able to do all the things with ease. So likewise, there are a lot of work happening. The company name is called as Boston Dynamics. If you go search in Google, you will get good information about the companies. And recently they have released a video for New Year that these robots are dancing, and it's really cool to see like how they are coordinating and or doing all these things. Some applications of machine learning are called as classification and clustering, which are identifying some special patterns. Now there are a lot of applications where we try to classify the objects into one or the other categories. You want to predict whether the email is spam or not spam. You want to identify based on the postal codes where does this letter belongs to, or something similar to that. So we are trying to create systems which are which we can do in the classification. Similarly, there are clustering techniques where we are trying to group different observations. We are trying to group customers based on their purchasing patterns. So we are trying to say that, okay, these people are high spending customers, these are low spending customers, these are regular customers. So based on the spending patterns, we are trying to group these people, and we are applying some rules to them. So if I know that there is a high spending customer, then I might not give discount coupons to him, because I already know that he or she will spend anyway. Why to waste my money by giving discount coupons? If I know like there are certain group of people who are only looking for 1+1 offer or some 20% discount like that, then I'll fire my discount coupons to them so that I can entice them to purchase more, right? I could do cross sell, upsell, and a lot of techniques are there based on which I can bring more business to the company by identifying these groups. So a lot of work is done in retail companies to identify the customer behavioral patterns. A lot of work is happening by applying these clustering techniques. Another interesting application areas are recommender systems used in data science. Now, recommender systems, as we know, these are available in every e-commerce company. If they are not having it, then they are lagging behind by the competition, because you are trying to entice people to purchase certain things which they might or might not require, but because you're trying to find out associations between the products, these recommender systems are created by identifying association rule mining. That means that we are trying to find out products which are very, very closely associated with whatever we are purchasing. So imagine I purchase a mobile, then you get these in the bottom saying that people who have purchased this mobile also purchase this credit, also purchase this scratch guard or case or whatever, or maybe some accessories. Now, how did I get those recommendations? Is because we are seeing that a lot of transactions are happening with these combination sets, and we are using that information to do recommendations to people who are purchasing. Now, if they find out some advantage, definitely they'll buy. So a person who is buying a mobile certainly would like to have a case for it. Probably he would like to go little secured and probably have a scratch guard for it and so on. So then when he sees that a deal that all these things are coming with a deal of 10% discount, then certainly he or she will go and do the purchase. Such a wise you are using recommender systems. Recommender systems are also used in media domains. You are seeing YouTube recommendation systems, and YouTube has grown leaps and bounds in the Corona time, the lockdown period. A lot of people did YouTube, watched YouTube videos, and there are a lot of recommendations which are nowhere related. And 4 or 5 years back, videos are also getting recommended because of this traffic has increased leaps and bounds. Another interesting area is transportation and car sharing. So these are the companies who have emerged in the past few years. These are the taxis, the Ubers and Olas, Lyfts of the world. They are using data science as a technology to improvise their experience, the customer experience, the productivity of the company and other things. So if you're taking an example of Uber, now Uber, if you want to improve the sales of the company or the profits of the company, what they have implemented is they have implemented surge pricing. So we know that surge pricing is purely based on something what we call as frequency analysis. So we are trying to identify the number of people who are searching for cabs, and we want to determine the demand of the cabs. Now, once we see that there is a huge demand of the cabs, what we can do is we can bump up the prices. So previously we are showing 100 rupees. Now, because there are a lot of people searching for cabs, we show it as 120. And slowly, if you wait, the price goes up 120, 140. Then you think that, okay, there's a lot of demand now. Let me book the cab right away. Fear of missing out, so that you book the cab. And then after 5 minutes, you see the price again settles down to 100. So this has practically happened, and I have experimented this. So I got down on a train, and right after you get down on the train, if you try to book a cab, you see that the price goes onto the top. So it goes to 200 rupees. The 100 rupees would go to 200 rupees. And then what you have to just do is you just sit down in the station, you get down slowly and relax. And once this crowd gets away, you see that the prices drops down. And it happens every time. I have experimented this in the railway station, I have experimented this in the airport and multiple other places. So what you have to do is get down, don't book the cabs right away, you just relax, take your luggage, sit and have a sip of coffee or whatever. You just relax and then you book the cab, then you see that the prices come down. The reason is because it's purely based on the demand supply. If more cabs are requested, there's a demand in the price, and certainly there will be cabs available. It is not like that you are losing out the opportunity. The cabs are there. So people have catched on this particular human psychology, and Uber and other companies have implemented surge pricing, which is purely based on demand analysis. These companies also have implemented intelligent systems which can identify driver positions. They're called as hotspots. Now, how do we identify hotspots? Hotspots are identified by the frequency analysis. We are trying to identify when the transaction is happening, where it is happening, and how many people are doing it. For example, every day I see that in say like a IT corridor or financial corridor, there's a lot of transactions happening from 5 p.m. in the evening to say 7 p.m. in the evening. So everybody is booking cabs to go back home. So we see that there is a lot of transaction happening during that time frame. Now, if I know that, okay, this is the hotspot and this is the time frame where the booking happened, I can send my drivers to that place. Likewise, there are a lot of hotspots decided based on the time of the day. For example, there could be a temple, there could be a masjid, there could be a shopping complex or area where certainly there's a peak times when the group of people come there and go. So based on that, these hotspots are created, and we can certainly identify that these drivers also can know the hotspots. So if they don't have a ride, they call these Uber, and the Uber will suggest that, okay, please go and stand in so and so location and you will get your next ride. So this is helping everybody. It is helping customers, because customers are certainly delighted, because as they open up their app, they see a cab in few minutes, so they are delighted. It will certainly help the cab drivers, because they don't have to drive the entire city. They just get pinpointed locations, they go there and stand, and they get their next cab. And from a company also, from a car company also, they are benefited, because they are not wasting the fuel, and having a happy driver and a happy customer. And so it is helping everybody. So it is a win-win situation. So using the technology, especially data science and data analysis, a lot of this kind of applications are created. Another interesting area is human emotion analysis. This is very interesting area, and a lot of research is happening in this space, where we are trying to use image analysis to identify the facial features of people and understand whether the persons are happy or sad or whatever, right? A lot of research is happening in this space also, where people are identifying the human emotions. We are trying to identify, based on the human emotions, we can take some decisions. And in the coming future, we would see that robots would take place of these monotonous jobs. For example, like a receptionist in a hotel. Now, if you are like a receptionist in a hotel, what is the general day-to-day task? People will come, they will give our reservation number. You will greet them saying that, hello, welcome, sir, welcome to Hilton Hotels. May I get your reservation number? They'll take that number, and then you will do the booking, and you will say, thank you very much for your stay. So this is what you regularly do. And these jobs can be automated and can be replaced by humanoid robots. Now you can have a kiosk system where people can go there and then give their reservation card. It will scan the card, identify, and based on that, it will interact with people and book the reservations. Such kind of things are being done in various customer locations like airports, hotels, where these receptionists or these other people are getting replaced by these humanoid robots. And now these humanoid robots are also getting equipped by facial expressions of people. Now they will know whether the person is happy or angry or sad, and based on that they will take next level escalations, right? If the person is really sad with the performance of the machine, then they say that, oh, let me call my manager, he or she will talk to you. So such kind of works are happening. Whichever can be automated, they are getting automated, and by including the facial expressions, the human emotion angle of it, they are able to treat people at a very higher level of sensitivity. One other interesting area, and this is called as genomic data analysis. It is purely working on human genes and relativity with other animals. So this is again in the medical domain. One interesting project we did is called as genomic data analysis, where we are trying to identify the gene similarity between humans and other lab animals. For example, if you want to release a drug, what you have to do is you have to go through different steps of drug testing. So you might have to test the drug on a lab rat, maybe on a bigger animal, maybe like a rabbit or a monkey or other kind of animals, and then finally you will test it on humans. Now this is a sequence of the steps which you need to certainly follow to get the drug onto the market. What will this step will provide you is it will provide you a sequence of steps in which you test that this is working on rats, this is working on rabbits, this is working on monkeys, and certainly there is a higher probability that this will work on humans as well. Now this testing time is a very long process. It takes a lot of time for this long process. So what you want to do is you want to avoid this testing process. So what you're doing is you're trying to use the technology. Just a second. So you're trying to use the technology and you are trying to make sure that how to cut down this testing time. So using data science, what we are trying to do is we are trying to find gene patterns of humans and other animals and identifying the genes which are similar. Now, if we are doing a lab test on rat, and if those genes are responding positively, and you identify that these genes are similar to humans, then what we can extrapolate is the experiments will be positive on humans also. So for example, there are a lot of genes similar to rats and humans, like they have eyesight, they have mouths for eating, and a lot of other similarities are there. Not the entire rat is similar to a human, but there are a couple of similarities, and the gene similarities, if they are matched and we are trying to identify the patterns, if something is working on the rats, the same things we can extrapolate and say that it will also work on humans. So what is it doing is it is reducing the drug discovery time. Drug discovery time is like where you're trying time to bring the drug to the market. I want to bring a a drug for COVID, or probably vaccine for COVID. To bring that to the market, you need to get this entire testing done, and there are different regulatory authorities who will do approve the drugs, and they will ensure that all these procedures are taken care. And once these procedures are taken care, and we are trying to get better drugs to the market, so that there are no side effects. So such kind of systems are being developed, and data science is being heavily used for doing these pattern recognitions. And one of the another interesting area is Internet of Things, and now this is like connected devices. Now I am very positive here that this again is going to change the world. We are going to see a world which is connected with all devices, and devices talking to each other, sharing information and other things like that. Such kind of things are going to happen in the world, and the application area which is about the Internet of Things is called as preventive maintenance of shop floor. Now this is a huge shop floor where a lot of machines are there, and they are doing some basic operations on certain things. And just imagine that these are machines connected one after the other, and once a certain thing is happening, then the product will be taken to the next machine and it will do something else like that. So this is like a production line, and every machine is connected with these sensors. Every machine is connected with temperature sensor, viscosity sensor, turbulence, and other gyroscope related sensors. All these things, what they will do is they'll try to identify the readings from the machine, and they will send it to a centralized system. The centralized system will identify all the readings from the machines and try to identify which machines will go bad in the coming few weeks. Maybe the turbulence of the lathe, which is the cutting machine, is not proper. Maybe the temperature of the machine is very hot because the rotating parts are jammed, or probably they are having some disturbance, or they are having some friction. So because of which the temperature is going higher and higher. So you wanted to identify those patterns well in advance so that your machine doesn't get stopped. Now, if you identify that the machine number 58 is having higher temperatures, please change the lubricant fluid, you know that well in advance, and then you take that action accordingly, rather than knowing it after the machine fails and then halts the entire production line. You wanted to know well in advance. So these kind of systems are implemented where we can apply data science for identifying patterns in the data and doing preventive maintenance of these shop floors. Other interesting application areas are these voice assistants. We know Siri, Cortana, Alexa, Google Assistant. We already discussed about these. These are used for providing better facilities for humans, where we can do speech-based transactions, and using the speech-based transactions, it will understand what the speech is, does the queries behind, and get back the results. Last but not the least, another interesting areas in the space of personalized medicine and healthcare. Now, as we are discussing, there are a lot of these medical, hospitals, and a lot of these companies. What they do is the hospitals capture a lot of medical information. So they are called as EMRs, electronic medical records. So every patient will get the medical record. So imagine I am going to hospital every month, or maybe every year. So my medical history is captured at the hospital as an electronic record. So they will capture all my bodily vitals. For example, what is my age, what is my height, weight, my blood pressure, blood sugar level, and other different vitals of my body. And they will capture all this information, and using that information, we can create clusters of patients. Now, how these clusters of patients will help is, if I know that the patient belongs to a certain group or a category, I can treat in the same way the group is treated. So in the previously, what people used to do is, if a person gets fever, he will be given one dosage of crocin. Just imagine one dosage of crocin is given to the person. Imagine one person is very, very fat, and this one dosage of crocin is not healing the person. For example, he get fever, and he goes to the doctor. Doctor gives one dosage of crocin, and this fat guy is not healed. And then he comes back after 3 days saying that, my fever is still persisting. Please give me other medication or treat me differently. The same dosage of crocin, if there is a lean girl who comes to the hospital, the doctor gives the same one dosage of crocin. The girl gets some side effects. So there's like, she gets vomiting, she gets nausea, and other things, like she get dizziness and other things. She get a lot of side effects because of the crocin. So what is happening here is, one dosage of crocin doesn't satisfy same people, right? So people might require little more dosages or little less dosages because of their bodily conditions. Now, for that, we want to personalize the medicine, and how we can personalize the medicine is if I can create groups of people who are belonging to, who are very lean, low weight, different body conditions, low height, and other things, and people are very fat and obese people, and other category. People who are healthy but they are having drinking, smoking habits, and they're having different kinds of habits, they can be grouped together. And people are very healthy who are doing regular exercise, going to jog, walk, whatever, and having a proper diet, so they can be grouped separately. Now once I group these people separately in different segments, patient segments, I can identify the patterns of the patients, what worked for those patients and what did not work, and based on that we will be able to treat them separately. So such kind of systems are being developed where a lot of these primary hospitals in US has adopted these kind of systems where they're trying to create customized groups, and based on that the doctors will get some meaningful clues of how to treat the patients. Now these clues are not going to replace doctors. Certainly we are not directly asking a computer to tell what is the medicine, but they will help doctors to take some meaningful decisions. So what they will do is they will try to give some advices or some meaningful clues so that the doctors can take right decisions. So it will complement the ability of the doctor. So using the technology, data science, machine learning, AI, and other technologies, we are trying to use all these applications. So what we did is we spent almost an hour or so to understand different applications and how they are used in the field of data science and in different application fields. Got it? So any questions? I would like to give a break here. Any questions on what we discussed? Are you guys following? Am I very fast? Is the pace okay?
Yes, it's okay.
Yes, yes, sir. That's good.
Good. So any questions? Feel free to put your questions on the chat, or we can discuss. If you have any general questions also, we could discuss. Right? So there's a question about the duration of the course. Okay, so I take a course on data science for 3 months, and that would cover full-fledged information right from basics. We would do math for data science, statistics for data science, Python Python for data science, and then we get into machine learning and other things. So there is a document, the curriculum document is there. I would request the organizers to send the curriculum document to everybody. So you could look at that and then identify what is the scope of the course and other things. The course generally what I would take would be a 3-month duration course. So we are doing some workshops now, but we're hoping to start a course by mid of February, or maybe 3rd week of February is what we are trying to start a course. All right. Any other questions? So there's a question asking that, do we need to get a certification from Google or IBM or Microsoft? No, depending, I would suggest, like, depending on what what is your experience level? I would say somebody who's already experienced, I would not recommend them to waste their money on certifications. Instead, I would ask them to do a lot of projects. Now, if you have a lot of project experience, if you are able to portray that experience to the interviewer, you will certainly get into the data science field. For somebody who is a fresher, it would require to get some kind of credentials to talk that, boss, I know this thing. So for such kind of people, I would recommend to do some low cost certifications just to say that, they know this technology, right? So some low cost certifications are provided by, IBM, TCS, and other companies. Oracle certification is there. You could go for high cost certifications like AWS and Google, but that will definitely not worth it, right? So go for a low cost certifications like somewhere around 3,000 rupees, 5,000 rupees. There are some certifications which would say like you are a data science certified, and that would help you to get into some of these roles. But for experienced people, I would not recommend, because most of them we are expecting to have some hands-on. Right? If you have some hands-on, your ability to do projects and show them, that is good enough. So there's a question, do I teach Python too? There is Python involved in data science, but as a base Python, I don't teach. So I would recommend, so you could get in touch with Career IT. There's some course running from Python. If you want to do that, certainly they will be able to help you, give some guidance. I teach Python for data science, which is involved in the course itself. So, all the things which are required for Python for data science, those I'll teach. I'll not teach like how to write a variable, how to write a class, how do you define it. So that is like basics of Python. So I might not be teaching that. Is SQL required? It's not mandatory, but it is good to have, because we would be doing some few SQL related things. So it's not mandatory, but if you know, it is good to have. Even if you don't know, it's not a problem. As a Python prerequisite, I would say any programming language is a prerequisite. So you need to know at least writing some programming language code or language kind of a thing. So that is something would I would say prerequisite. It doesn't matter if it is a Java or C or C++ or any other thing, but it is recommended to have some programming background. So Python, what I teach in data science is for data science. Yes, that is correct. So whatever Python we talk in data science is pertaining to the data science part. It might not help you in creating web applications or something like that. It's purely for data science. Yes. So this course covers a complex real-time ML training, and it does not use AWS. So what we do is we have cloud computing for data science. We will cover a portion in which we talk about cloud computing for data science. And that's where we will talk about how to deploy models onto cloud and so on. We would also talk about DevOps for data science, which will also be covered. So those are areas where we will cover about those applications, but it will work on project-oriented training, which will work on the complex machine learning algorithms, and we might not be using any pre-built tools from AWS or Google. So in this 3 months, we will be covering the big data, Spark, and streaming and ML. So this course is on the data science. We would not be covering on the big data space. We would not be covering on the Spark space. We'll be covering on the machine learning modeling. We would be covering on data science and data preprocessing and all those things. which is the next step of all this big data related stuff. All right. So I'll not be teaching on Hadoop or Spark or any other things. We will be talking on data processing, data pre-processing techniques, different modeling techniques, predictive analytics, machine learning, deep learning. These are the tools we will be talking on. Course would be the course timing every day 1 hour. Generally happens in the morning IST time. If you are in the EST time zone or different time zones, typically it will be in the evening times. But generally the course would run from 7 a.m. to 8 a.m. IST, 1 hour every weekday, and for 3 months. 3 months is a rough timeline, but somewhere around 2.5 to 3 months is a tentative timeline.